Okay, so this is a new, it still deals with exponents and the reverse, I guess you can think of it, but we are going to talk about simplifying radicals, okay? A radical is referring to an expression with the radical symbol, or in this case, a square root symbol. But there are many types. So there's square root, which is finding what number times itself. Cube root, which is what number times itself, times itself, times itself 3 times. Fourth root, times itself, times itself, times itself, times itself 4 times. And the fifth root, and etc. But in algebra, we only focus on square roots and cube roots, okay? So let's jump into square roots. Square roots, okay, is asking yourself, okay, what number times itself can I get to get the number inside the radical, okay? So these first 6 examples are actually perfect squares. So, I mean, we're not going to see them written like this. So what I mean by perfect squares is the square root of 625 is 25. The square root of 576 is 24. Perfect squares. And we're going to talk about imperfect squares, or not perfect squares, here in a minute. So the square root of 4 is 2, because 2 times 2 is 4. The square root of 81 is 9, because 9 times 9 is 81. The square root of 256 is 16, because 16 times 16 is 256. The square root of 121 is 11, because 11 times 11 is 121. The square root of 36 is 6, and then the square root of 484 is 22. Okay, so these are considered perfect squares. But when we're dealing with non-perfect squares, okay, we have to think about breaking it up into the highest perfect square I can think of and see what's left. So if I look at the square root of 162, 162 is not a perfect square according to my list. So I'm going to see what is the highest perfect square that can be divided into 162. So I tell my kids, and this is just a tip, I'm going to look at here. 162 would be right here between 12 and 13. So I'm just going to test to see if I do 162 divided by 144, it comes out to decimal, and that's what I don't want. So I'm just going to keep testing. So I'm going to do 162 divided by 121, again another decimal. 162 divided by 100, another decimal. 162 divided by 81, and here it is. So if you look, I kept trying until I came out to a whole number. So my 162 can be broken up into a perfect square of 81 and 2, because 81 times 2 is 162. Now, the reason why we do this is I can only take the square root of perfect squares to bring them out, okay? So here's how it works. What's the square root of 81? Well, the square root of 81 is 9. So 9 is going to be outside the radical, and I'm left with 2 inside the radical, okay? And then if I want to check this, I do 1 square root of 162 is this decimal, and if I type in 9 square root of 9 square root of 2, I get the same exact decimal. Okay, so let's practice some more, because I know that was probably like over your head. Over mine too sometimes. All right, 245 is not a perfect square according to my list, but the highest I can go is right here. So I'm going to check to see what is the highest perfect square that I can get. So I'm going to try 245 divided by 225, not perfect. 245 divided by 196, still a decimal. 245 divided by 169, still a decimal. 245 divided by 144, still a decimal. 245 divided by 121, 245 divided by 100, and sometimes it's really just trial and error. Still a decimal. 245 divided by 81, still a decimal. 245 divided by 64, 245 divided by 49. Oops, did that wrong. And there it is. So I have 49 and 5. So 245 can be broken up into 49 and 5. 49 times 5 is 245. And that was the highest perfect square that could go into 245. And so the square root of 49 is 7, so that gets pulled out. And then the square root of what I'm left with is 5. And again, I can check this by typing this in. So the square root of 245 compared to 7 square root of 5 is the same decimal. And there we go. Okay, let's take another one. The square root of 343. So 343 would be right here. So I'm going to try to see which one is the highest perfect square that can go into it. So 343 divided by 324. Crazy decimal. 343 divided by 289. 343 divided by 256. 343 divided by 225. 343 divided by 196. 343 divided by 169. 343 divided by 144. 343 divided by 121. 343 divided by 100. 343 divided by 81. 343 divided by 64. 343 divided by 49. There it is. So this one can be broken up into 49 and 7. Okay. So the perfect square is 49. The square root of 49 is 7. So I'm going to pull 7 out. And I'm left with the prime number 7 inside. Now, I will say the reason why I work backwards is there could be more than one perfect square that goes into 343 or 245 or 162. But we don't want to go with the first one that is in the list. We want to go with the highest that it could possibly be. So you can try going from low to high, but then you're going to try to stop whenever it could be a number higher than that. So just be careful. All right, let's do a few more here. Square root of 117. Oops, what am I doing? 117 is right here. So I'm going to try 117 divided by 100, 117 divided by 81, 117 divided by 64, 117 divided by 49, 117 divided by 36, 117 divided by 25, 117 divided by 16, and 117 divided by 9. Okay, so 9 ends up being the highest perfect square that I can break this up into, so 9 and 13. If you notice something about the numbers I'm left with, these are called prime numbers. That's because nothing else can go into it. So that's another way you know you're on the right track. So the square root of 9 is 3, so 3 comes outside the radical, and then I'm left with the prime number of 13. Okay, 2 more examples. So 28, okay. 28 divided by 25 doesn't work. 28 divided by 16 doesn't work. 28 divided by 9. 28 divided by 4. So the highest perfect square into 28 is 4 times 7. The square root of 4 is 2. And I'm left with 7 in the radical. Okay, last but not least, 450. So notice it's the same process every time. It's just finding the highest perfect square and then seeing what I'm left with inside the radical. So 450 is divided by 484 doesn't work. 450 divided by 441. 450 divided by 361. 450 divided by 324. 450 divided by 289. 450 divided by 256. 450 divided by 225. There it is. So my highest perfect square is 225 and 2. I do want to point out on this one that 450 can be divided by 9, which is another perfect square. But see, this is why I work backwards, because you have to go with the highest. So that's just a tip. Okay, the perfect square is 225. The square root of 225 is 15. And I'm left with 2 inside the parentheses. Okay, so I'm going to go over more examples on these non-perfect roots at the end of the video. So I'm going to go ahead and jump into cube roots. So if you want to keep watching, I'll go over some more of those here in a little bit. But cube roots is the same idea, but it's a whole new list. So here are my list of perfect cubes. This will be posted on Google Classroom. And the idea is the same exact thing, okay? So we have our perfect cubes. So 8, the cube root is 2, because 2 times 2 times 2 is 8. 125, the cube root of 125 is or negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is negative 125. And the cube root of 729 is 9, because 9 times 9 times 9 is 729. So those are cube roots. These are the ones that we probably do not have memorized, like the perfect squares, but we do have to practice them. So the idea is the same when we're talking about cube roots. Okay, we're going to use our cube root list to narrow down what is the highest perfect cube that breaks up into. So if I look at negative 16, negative 16 goes right here. So negative 16 divided by 8 can be broken up into 8 and negative, or 8 and negative 2, okay? Okay, is negative 8 and positive 2. So the cube root of 8 is 2, so I'm going to pull out negative 2, and I'm left with the cube root of 2 inside the radical. So if I look at 432, 432 can go here. 432 divided by 343 doesn't work. 432 divided by 216 does work. There we go. So it can be broken up into 216 and 2. The cube root of 216 is 6, and the cube root of 2, which is left inside. Okay, if I look at number 18, I have negative 320, which can go here. Negative 320 divided by 216. Negative 320 divided by 125. Negative 320 divided by 64. So there is my highest radical, is negative 64 and 5. Okay, and the reason why we have to bring out the negative is because you can't have a negative under a radical, okay, when you're simplifying. So just keep that in mind. Okay, so the cube root of 64 is 4. So negative 4 and the cube root of positive 5. 1954. 54 divided by 27. There's my highest cube root. So 27 and 2. The cube root of 27 is 3, and the cube root of 2 remaining inside. Okay, 96. 96 divided by 64 doesn't work. 96 divided by 27 doesn't work. 96 divided by 8 does work. So my highest cube root is 8 and 12. The cube root of 8 is 2, and I'm left with the cube root of 12 underneath the radical. Okay, number 21, negative 875. Imagine where it would be without the desk or without the calculator. 875 divided by 729 does not work. 875 divided by 512 does not work. 875 divided by 343 doesn't work. 875 divided by 216. 875 divided by 125 does work. So my highest cube root is 125 and 7. Again, we want to pull out that negative. So the cube root of 125 is negative 5, and the cube root of 7 inside the radical. Okay, 3 more on the front. 648. So 648 divided by 512 doesn't work. 648 divided by 216 does work. So my highest cube root is 216 and 3. The cube root of 216 is 6, so 6 and the cube root of 3 remaining. Okay, negative 297. 297 divided by 216, 297, doesn't work. 297 divided by 125, doesn't work. 297 divided by 64, 297 divided by 27. So my highest cube root is 27 and 11. Again, I want to pull out that negative. So the cube root of 27 is 3, and the cube root of 11 remaining. Okay, last one on the front, 686. 686 divided by 512. 686 divided by 343 is my highest cube root, so 343 and 2. The cube root of 343 is 7, and I'm left with 2 inside the radical. So this is a quick little lesson about perfect squares, non-perfect squares, and cubes and non-perfect cubes. So I'm going to make a separate video for just the back, which is just practice of the non-perfect roots and the non-perfect cubes. So I'm going to include both into Google Classroom, so be sure to watch if this wasn't enough review for you.